Good morning, students. Today we are going to see the topic compiler design. I am S. Srividya, Assistant Professor of CSE Department from Erode Engineering College. Now we are going to see about the introduction. First of all, we have to know what is meant by compiler, then what is translator. First, we will see the basic. Compiler. A compiler translates a code written in one language to some other language without changing the meaning of the program. Compiler means a code that is written from, that is we are writing it in assembly language and then we are converting it into the high level language. So for that we are going to use a translator to translate the languages, that is called as a compiler. Compiler used to show errors to the programmer. For example, in C we are compiling, no? Like that. In that we are seeing the errors. What are the errors we have done in the program? So that is the compiler. Then comes the translator. Translator is a kind of program that takes one form of program as an input and converts it into another form of a program. That is called as translator. So first we have seen what is a compiler and then a translator. Next comes the topic we have to know in compiler design is that language processing system. We have learned that any computer system is made of hardware and software. The hardware understands a language which humans cannot understand. So usually we know that hardware doesn't understand the human language. So we write programs in high level languages which is easier for us to understand and remember. So usually in what language we are using C program, a basic English only, so the same, that is the concept. So we write programs in high level language which is easier for us to understand and remember. These programs are then fed into a series of tools and OS components to get the desired output that can be used by the machine. So we are typing a C program. We are using a what component? We are using the OS component, and we have to get the desired code. We are going to use the machine, and we will get the output. This is known as the language processing system. Then comes here how it runs. So here it is first one. Source code first enter into the preprocessor, then it is converted into preprocessor code, and then it enters into a compiler, then it translates into target assembly code, then it enters into the assembler. In assembler it is relocatable machine code, and it is converted to sent to linker. Linker is nothing but library files, modules. These are the, from linker we are getting the executable machine code, and then it enters into the loader, then into the memory. This is the process of the language processing system. We will see one by one what is preprocessor, what is assembler, what is linker, loader, memory, everything. Before that, this is the high level language is converted into binary language in various phases. A compiler is a program that converts. Already we have seen a compiler. That is a program that converts high level language to assembly language. Similarly, an assembler is a program that converts the assembly language to machine level language. So let us first understand how a program using C compiler is executed on a host machine. First, user writes a program in C language, that is high level language. Then the C compiler, what it will be done? So it compiles the program and translates it into the assembly program. Then what the assembler will do? An assembler that translates the assembly program into machine code. Then comes a linker tool, is used to link all the parts of the program together for execution. Then a loader loads all of them into memory and then program is executed. First, we will see what is preprocessor. A preprocessor generally considered as a part of a compiler. That is a tool that produces input for compilers. Next comes, it deals with macro processing, augmentation, file inclusion, language extension, etc. Next comes the interpreter. What is interpreter? An interpreter, like a, it is also like a compiler which translates high level language into low level machine language. The difference between the compiler and the interpreter is in the way they read the source code or the input. A compiler, what a compiler will do is, a compiler will read the whole source program at once and it creates tokens. So usually a compiler is converting the whole, it is taking the whole source code at once and then it creates as a tokens. Then check semantics, then it generates intermediate code, then executes the whole program and may involve many passes. In contrast, but as an interpreter, it reads a statement from the input, converts it to an intermediate code, then it executes it, then takes the next statement in sequence. What the main difference between the compiler and interpreter is, compiler will convert, it will take the whole source code and then it creates a token, then it do some it does some many passes. But as an interpreter, it is taking each and every statement as an input from the input and then it converts into the intermediate code, then it executes, then only it will take the next statement. So each and every statement, line by line, it is executing. That is the main difference between the compiler and the interpreter. If an error occurs, if suppose an error occurs, then what does it do? An interpreter stop execution and report it. Whereas a compiler reads the whole program even if it encounters several errors. The other difference is nothing but, we can take the example as a Python and C. In C, what we will do, it takes, we will type all the lines, then we will compile, then only it shows the errors. But in Python, if you take in Python, while we are typing itself, it shows the first statement. If it contains error, it stops. Then it will show it there is some error in this line. So that is the main we will take as an, for our remembrance, we will take Python and C. So in C program, it will take, we have to type the whole program. If in between there is an error, we doesn't know. But in Python, we can see if in first statement, if we have an error, it will show then and there. That is the difference between the compiler and interpreter. So both is used to convert a language from one language to another language, but the main difference, it takes a whole source code, but interpreter takes a statement, each and every statement as an input and execute it. This is the main difference. Everyone have understand what is the difference between the interpreter and the compiler? Okay, then let's move next. Next topic is the assembler. An assembler translates assembly language programs into machine code. So assembler also, what it does, it is also translating some assembly language programs into the machine code, not to the program, converts into machine code. The output of an assembler is called an object file, which contains a combination of machine instruction as well as the data required to place these instructions in memory. This is the assembler's work. Next comes the linker. Linker is a computer program that links and merges various object files together in order to make an executable file. Usually linker. So link means itself, it is a how to say, just it links. For example, we can take the train. Each and every compartment is linked, no, the same. So linker means it is a computer program that links and merges various objects files together in order to make an executable file. So all these files might have been compiled by separate assemblers. So the major task of a linker, what is a major task is to search and then to locate referenced module or routines in a program, and to determine the memory location where these codes will be loaded, making the program instruction to have a absolute references. Next comes the loader. Loader is a part of operating system and is responsible for loading executable files into memory and execute them. So loader is also a part of operating system. Next, it calculates what it does. It calculates the size of a program, that is instructions and data, and creates memory space for it. It initializes various registers to initiate execution. This is the loader's work. Next comes the cross compiler. A compiler that runs on platform A and is capable of generating executable code for platform B is called cross compiler. So what it is doing, it is a compiler that runs on a one platform and it is capable of generating executable code for some other platform. So that is the cross compiler. Next comes the source to source compiler. A compiler that takes the source code of one programming language. So source to source, that means a compiler is taking one programming language source code and translate it another programming language source code. That is called the source to source compiler. So the cross compiler and source to source compiler. Next we are going to see, I have already told you the difference between the compiler and the interpreter. So compiler converts high level to low level language. Interpreter also converts high level to low level language, but line by line. So next point, source program can be analyzed only once. Here source program analyzed every time. While we are typing, it starts analyzing each and every time. Then it produces object code, but interpreter does not produce any object code. Compiler requires large memory, interpreter requires small amount of memory. I have told you the difference C, and we will take the example as C and Python. No, that is only used by C, C++, .NET, Java, etc. are used by the compiler, but interpreter is used by the Python, Perl, etc. This is the difference between the compiler and interpreter. Everyone have, I think I'm saying it clearly. So next we will move with the next topic. That is the structure of compiler. So in this, a compiler can broadly be divided into two phases. The structure is divided into two phases on the way they compile. So how we are dividing it into two phases? On the way they compile. How they compile? They are dividing into two phases. One is the analysis phase, one more is the synthesis phase. First we will see what is analysis phase. Analysis phase is nothing but known as the front end of the compiler. The analysis phase of the compiler reads the source program, divides it into core parts and then checks for lexical grammar and syntax error. So in analysis phase, what is done? It is the front end. Synthesis phase is the back end of the compiler. So in analysis phase, it reads the source program, whatever we are typing, it reads, and it is dividing into core parts, and then it is checking for lexical grammar and syntax error. What does mean by lexical grammar? What does mean by syntax error? I'll tell you in this video at the last. Okay, just you know, in analysis phase, it is taking the whole source, it reads the source program and it converts into core parts. The analysis phase generates an intermediate representation of the source program and symbol table, which should be fed to the synthesis phase as input. So for this, first source code is there, it is entering into the analysis phase, then after that it is converting into the intermediate, that is a source program and symbol table, that is the input for the synthesis phase. So next comes the synthesis phase. Synthesis phase is known as the back end. You have, if anybody is asking about the compiler, what are the two phases, you have to answer. One is the analysis phase, one more is the synthesis phase. Analysis phase is the front end, synthesis phase is the back end. So known as the back end of the compiler. The synthesis phase generates the target program with the help of intermediate source code representation. So in this diagram, I have represented you in the previous slide. I have shown you the diagram. In that, it enters the intermediate source code representation and symbol table. A compiler can have many phases and passes. So next, what does mean by pass? What does mean by phase? Pass means nothing but it refers to the traversal of the compiler through the entire program. Phases is nothing but a phase of a compiler is a distinguishable stage which it takes input from the previous stage. So phases is nothing but that is taking the input from the previous stage, processes and yields the output, and it can be used as an input for the another phase or the next stage. That is the phase. So a pass can have more than one phase. So next comes the important topic, that is the phases of a compiler. So phases of a compiler. The compilation process is a sequence of various phases. Each phase takes input from its previous stage, has its own representation of the source program, and feeds its output to the next phases of the compiler. So in phases of compiler, each phase is it is taking the input from the previous stage and it processes it and it gives the output, and it moves to the it is converted as an input for the next phase. So let us understand the phases of a compiler. This is the diagram. So once source code is entering, these are the phases of a compiler. One is the lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator, machine independent code optimizer, code generator, machine dependent code generator, and finally it reaches the target code. The side there is symbol table and error handler. So this we will see the explanation of this each and every phases. First one is the lexical analysis. Lexical analysis means in a compiler, linear analysis is called lexical analysis or scanning. For example, in lexical analysis, the characters in the assignment statement. See the example. If we have a statement, position is equal to initial plus rate star 60. How it is converted into the tokens? First point, the identifier position. Next is the assignment symbol. Here the text all is considered as the identifier. So that is the first one. Next equal to is the assignment symbol. Then initial is considered as the I told you the words. So that is the identifier. So third one is the identifier initial. Then plus symbol. So that is the plus sign. Next comes the once again rate. So that is the identifier. Then multiplication sign. The last is the considered as the number. So the blank separating the characters of these tokens will be eliminated during the phase. Any blanks are there that will be not be considered. So next it enters into the syntax analysis. So first, what is the work of lexical analysis is if a statement is there, it starts to uh, analyze what that text all is considered as the identifier. Next, symbols are considered as the symbols, and last numbers are considered as the numbers. In this, you have to know the wordings all is considered as the identifiers. So next comes the syntax analysis. So uh, hierarchical analysis is called parsing or syntax analysis. It involves grouping the tokens of the source program. So here it starts in lexical analysis phase. What it does, it separates the everything into tokens. That is, it is that position is considered as the identifier. That is one token. Then star, that is the symbol. Then comes the plus, that is the symbol. So everything is converted into token. So that here it involves grouping the tokens of the source program into grammatical phrases that are used by the compiler to synthesize the output. The source program is represented by a parse tree. In this phase, it converts into parse tree. First, it takes the assignment operator, that is the common. So that is the center. So we are taking the assignment operator as the first one. Then position is the identifier this side. After that, it comes the one star symbol is there. Then one rate, that is the identifier. This side it comes, sorry, initial. Then it comes star, that splits into rate and number. So that equation we have seen, no, position that is equal to initial plus rate star 60. So that expression is totally converted into the parse tree. That is the image representation of this which is present in this slide. Next, see, for that the explanation. The hierarchical structure of a program is expressed by recursive rules, that is context-free grammars. The following rules define an expression. First, an identifier is an expression. So that is E determines ID. Any number is an expression, that is E determines num. If expression 1 E1 and expression 2 E2 are expressions, then we can form like this expression. So rules 1 and 2 are basic rules which are non-recursive, while rule 3 define expression in terms of operator applied to other expression. So next comes the next phase is the semantic analysis phase. In this, the semantic analysis phase checks the source program for semantic errors and gathers type information for the subsequent code generation phase. Then it checks only for the semantic errors. If not, it moves into the code generation phase. An important component of semantic analysis is type checking, that is whether the operands are type compatible. For example, a real number used to an index and array. So there is a two different. First one, it comes the same statement, the same diagram parse tree. So colon is equal to, this is position plus initial. So here rate, here we have the whole number. But in the semantic analysis phase, what it does, it represents this number is, that is the integer. No, if we want to convert that integer to real, we want the output in real. So for that we can represent it into real and then the number. So this conversion is done through the semantic analysis phase. Next comes the intermediate code generation. After semantic analysis, some compilers generate an explicit intermediate representation of the source program. This representation should be easy to produce and easy to translate into the target program. There are variety of forms. Here three address code. One is postfix notation. There are variety of forms. One is the three address code, postfix notation, syntax, tree. The commonly used representation is commonly we will use the three address format. The format consists of a sequence of instruction, each of which has at most three operands. Students, you know this is operand and what is the operators, everything, right? The IR code for the given input is as follows. Here what it is considering, first int to real. That semantic diagram is there, no? From that, sorry, int to real is the, it is taking as a temporary variable 1. Then next statement id3 to temp1 is considered as the temporary variable 2. Then id2 plus temp2 is equal to temporary variable 3. Then id1. So that previous diagram is converted into the code like this. Everything is assigned to a variable. Next comes the code generation. In this phase attempts to improve the intermediate code so that faster running machine code will result. There is a better way to perform the same calculation for the above three address code, which is given as follows. So in this, just we can from that statement it starts to what shorten the code. So temporary variable 1 is equal to id3 star 60. Then id1 is equal to id2 plus temp1. So there are various techniques used by optimizing compilers such as common sub-expression elimination, dead code elimination, constant folding, copy propagation, induction variable elimination, code motion, reduction in strength, etc. There are many optimizations techniques are available in the code optimization. So each and everything we will see in the next units. Next video I will explain you. Next comes here code generation. The final phase of the compiler is the generation of the target code consisting of relocatable machine code or assembly code. The intermediate instructions are each translated into sequence of machine instructions that perform the same task. A crucial aspect is the assignment of variables to register. So in this code generation, everything will be considered as the registers. So using register R1 and R2, the translation of the given example. So now what it is doing, we are using the target code consisting of relocatable machine code or assembly final phase of a compiler. In this we are moving move id3 comma R2. Then what we are doing, multiplying that with R2 and 60 we are going to multiply. Then comes the statement. You remember the statement, position is equal to initial plus rate star 60. That statement finally is converted into the finally it is converted into generation of the target code consisting of machine code or as a assembly code. So this is called as the assembly code. So move the id2 to register 1. Then we are adding the R2 output with the R1 output. Then we are moving the whatever output present in the R1 to the id1 because position is equal to. So that is the statement, right? Position is equal to, what is the statement? Initial plus rate star 60. So what first it will do? In first phase it is a position is considered as the id1, right? That is equal to initial is considered as the id2, then plus, then rate is considered as the id3, then star 60. No, so first we will multiply it. So that identify. Next we will, what we will do, we will get an output that is stored in a one register. Then we have to add the id2 with that register. So we are adding it and we will get an output that is used in one register. Then from that register everything is moved to the id1. That is the explanation of this statements. Hope you understand, right? Okay, next comes the symbol table and error. Symbol table management is nothing but An essential function of a compiler is to record the identifier used in the source program and collect its information. A simple table is a data structure containing a record for each identifier with fields of attributes. The data structure allows to find the record for each identifier and store or retrieve data from that record quickly. So this is the symbol table management. Next comes the error handling. In this, each phase can encounter errors. After detecting an error, a phase must deal that error so that compilation can proceed. So error handling is nothing but the what it is doing. The lexical phase can detect errors where the characters remaining in the input do not form any token. Next, so this is the diagrammatic representation of the phases of a compiler. We have seen the first phase is the lexical phase, next is syntax, semantic, intermediate code generator, code generation, then code optimize. So that is the phases of the compiler, right? So see, this is position. So this is the statement entering as a source code. Lexical analyzer converts into the, you can see id1 that is equal to id2 plus id3 star 60. From the, it enters as a input for the syntax analyzer. Syntax analyzer, what it does, it is converting it into a parse tree. So it is splitting into a tree, then it enters into the semantic analyzer. Just if we have a numbers, it is converting whether it is we need an into real or float or whatever it is. So that process is undergoing in semantic analyzer. Then it enters into the intermediate code generator. In that, it is everything is stored in the temporary variable. First step, we have to take first variable into real. We are taking as the temporary variable 1, and then in second, you see id3 here. Star left of the star, there is the id3. So we have to do id3 star int. So for that, how we can write temporary variable 2 is equal to id3 star temporary variable 1, because we have moved this into real into the temporary variable 1. Next statement, temporary variable 3. Next here is the id2 plus this whole thing, right? So everything is available in the temporary variable 2. So we can write temporary variable 3 is equal to id2 plus temporary variable 2. Next, everything id1 is equal to temp3. Next, it enters into the code optimizer. Optimizer, it reduces the code, right? So here commonly it takes the temporary variable 1 is equal to what we can write id3 star. Instead of this temp1, it is taking 60.0 because it converts into real, right? So 60.0. Then id1 is equal to temp3, no? So for that temp3, what is the temp3? id2 plus temp1. So fine, it produces the, it converts the code. We have many lines, so it shortens the code optimizer. Next enters into the code generator. It converts into the assembly language. This is the function of the phases of a compiler. So thank you, students. I hope that you have understand what is a compiler, what is interpreter, what is assembler, what is preprocessor. Everything is just an introduction of a compiler design. In first unit, it covers the introduction, and I have given the explanation of the phases of a compiler. Thank you.